Hello everybody! In this lesson, I will discuss the 4 exam questions you find below on geometry of 2D figures. Now before I start, remember you have your 2 maths toolboxes with all your reasons inside. Question 1. O is the center of the circle and angle C1 is equal to angle C2 is equal to 90 degrees. So that implies that you are dealing with 2 right angle triangles. The question, prove that AC is equal to CB. Now before we start with the question, I want you to go to the sketch. The fact that there is a midpoint or a center of the circle, that implies that side OA and OB, they are radii of that circle. Therefore, they are equal. Now, let's look at this. Once we can prove that the 2 triangles are congruent, the deduction that we can make, or the conclusion that we can make, is that the congruency means that the 2 triangles are exactly equal. Therefore, the side AC will be equal to side CB. So let's try and prove the 2 triangles congruent. We can start by saying in triangle AOC and triangle OCB. OC is equal to OC. That one is the common side. Angle C1 is equal to angle C2. That was given. They are both 90 degrees. And then this is the hidden part, that OA is equal to OB since they are radii. Therefore, we can say that triangle AOC is congruent to triangle OCB, and our reason RHS, right angle, hypotenuse and side. And then, as I said, because of the congruency, we can say that AC is equal to CB, and your reason because of congruency. Question 2. Given triangle ABC and triangle DEF. Number 2.1. Determine the size of angle C and angle D. Now, it's very clear that this angle there at C is the third angle of the triangle. And in our little red toolbox, we have a theorem that says the interior angles of a triangle are supplementary. Supplementary means they add up to 180 degrees. So we can start by saying that angle C plus B, which is 35 degrees, plus A, which is 85 degrees, is equal to 180 degrees. And your reason, angles of a triangle. And then we can add them. 35 plus 85 is 120. Let the 120 walk across. C is 180 minus 120. Therefore, C size is 60 degrees. And then the second part of our question was they also wanted the size of angle D. Again, we'll use the same theorem, angles of a triangle, which are supplementary. So we can start by saying angle D plus angle E, which is 35, plus angle F, which is 60, is equal to 180 degrees. And remember, you have to add your reason, angles of a triangle, supplementary. And then we can say 35 plus 60 is 95. And to solve D, let the 95 walk across. D is 180 minus 95. Therefore, D is 85 degrees. Question 2.2. Show that triangle ABC is similar to triangle DEF. Now, from the previous slide, we know that in the little triangle ABC, angle C was 60 degrees. We calculated that. And in the big triangle DEF, angle D was 85 degrees. Now, back to the question. We have to prove the two triangles similar. And to do that, remember, we need to prove that three angles are equal. So we can start by saying, in triangle ABC and triangle DEF, angle A is equal to angle D, 85 degrees. Both were given. We can say that angle B is equal to angle E, both are 35 degrees. And angle C is equal to angle F, both is equal to 60 degrees. Therefore, triangle ABC is similar to triangle DEF, and our reason, angle, angle, angle. Question 2.3 on the left hand side, determine the length of AB. Now remember, when we have proven that the two triangles are similar, we can write down the ratios. So we can start by saying that the ratio AB over DE is equal to the ratio BC over EF is equal to the ratio AC over DF. And you have to say, you can write that because the triangles are similar. Then AB over, now DE was given that it's 6,5, is equal to BC over EF. BC is 3 and EF is 7,5. And then to solve AB, we will simply multiply away the 6,5. Therefore, AB is 6,5 times 3 over 7,5 and the length 2,6. Before we continue, have you subscribed yet? Or you can like this video, and better yet, please tell your friends about my channel. Let's continue. Question 3. In the diagram, side AB is equal to side DC and AB is parallel to DC. Prove that triangle ABC is congruent to triangle CDA. Now we can start by saying in triangle ABC and triangle ACD, we find the following. Let's always go to what's given. Side AB was equal to DC, that's given. Furthermore, there's parallel lines. And because there's parallel lines, we have a theorem in our toolbox that says that angle A2 will be equal to angle C2. And the reason is they form alternate angles equal. And then it's very clear that AC is the common side. So you write AC is equal to AC, common side. Therefore, triangle ABC is congruent to triangle ACD. And your reason, side included angle, side. Question 4 wants us to show that triangle ABC is similar to triangle EDC. So we'll start with in triangle ABC and triangle EDC, the following is happening. Now remember, usually when we want to prove that two triangles are similar, we need to prove that three angles are equal. But in this case, there's no angles given, only the lengths of the sides. But we have another theorem, and with that one, if we can prove that the three sides are in the same proportion or ratio, then the two triangles will be similar. And let's start with this. We say the longest side over the longest side. So in triangle ABC, the longest side is BC over CD, which is 8 over 12, and that simplifies to 2 over 3. The next thing we do is we say the second longest side over the second longest side is AB over DE, which is 5 over 7,5, and that simplifies to 2 over 3. And then the shortest side over the shortest side will be AC over CE, which is 3 over 4,5, and that simplifies to 2 over 3. Therefore, we can say that the ratio BC over CD is equal to the ratio AB over DE is equal to the ratio AC over CE, and they are all equal to 2 over 3. Therefore, triangle ABC is indeed similar to triangle EDC, and our reason, the sides in proportion. Thank you for watching my videos. Remember, I prepared the whole syllabus for you. This is Miss Pythagoras signing off. Till next time.